Last time we started section 14.5, we were talking about volume, mass, and temperature. Hadn't gotten too far into it, but we're on the second page of notes, and we're taking a look at converting some quantities. We talked last time about King Henry died by drinking chocolate milk. We can use that acronym again. And we are moving from meters cubed in the first problem into liters. So I'd like for you to take a look back. I think it's the slide right before this. Let's see. We're looking for a relationship between cubic meters, hang on, cubic meters and liters. So do you find a relationship between cubic meters and liters anywhere on this particular slide? The problem A, meters cubed, M cubed, and liters.
Centimeters.
There's close. There's one that's almost right. Which one do you see? Which line are you on, Hannah?
The third one.
The third one. So you're looking at this relationship. This one? Okay. So I could change my cubic meters into cubic centimeters. And then I can convert cubic centimeters into liters. Fantastic. That's what we're going to do. Good eye. So we're going to take our 4.6 cubic meters into centimeters. And so just as a practicing sort of thing, I told you we could do this last time, and so I want to show you that we can. Here's my base unit, and I'm trying to turn it into centimeters cubed. So that's actually 2 decimal places I'm going to move it, correct? To the right or left? To the right. So if I were doing just plain old centimeters, I'd move it 2 to the right. But this is cubic, so what will I do? You'll move it 6. You'll do it 3 times. So we're going to move it 2 to the right 3 times. So there's our second move, and here's our third move. So the location where I currently am is 460,000. I'm not sure how many I've got here. 4,600,000. That's what I have. And it's in cubic meters, cubic centimeters now. Which isn't exactly where I was asked to go, but it's a good place to start. Now going between the cubic centimeters and liters, the relationship that it shows us is that 1,000 cubic centimeters is 1 liter, right? So if you want to set up your picket fences or your railroad tracks, this is a good place to do that. It says 1,000 cubic centimeters is equal to 1 liter. So you're going to take this 4,600,000 number and divide it by 1,000, which will in essence do what? That red was a terrible choice. It will do what? Yeah, it'll take off 3 zeros at the end. Zeros are the only numbers that do that, of course. We can't just start taking off numbers everywhere, but we end up with 4,600 or 4,600 liters. And it's not cubed, it's just liters.
How do we know it's not? How does it go from cubed to not being cubed?
Liters is already a measurement that is cubed. Remember when we ended last time we were talking about, it's kind of like when we did acres and airs. Those are already square measurements. This is already a cubic measurement because it's a capacity measurement. Yeah. And if that feels uncomfortable, you can also just rely back upon the tables themselves where they've got them in there appropriately and remind yourself that way too.
So would we ever write liters cubed?
No, because it's already in cubic measurements. It's already a cubic measurement. Yeah. It's kind of like you'd never write cubic gallons, right?
Right.
I mean, gallons are, it's usually done with liquid, right? Liquid measurement. Liters the same thing. It's usually done a liquid measurement. All right, we've got millimeters cubed, decimeters cubed. So we don't need anything from my other slide on this one, right? They're both cubic measurements. They're both metric measurements. Let's take a look at where we are on our acronym above. Where is the millimeters going to be? That's my far right. And where will decimeters, DM, be? 2 to the left. So we're going to move it 2 to the left, but this is cubic, so we're going to do it 3 times. So in essence, we're going to move it 6 to the left, right? So we're starting with 365. Here's my decimal point. That's 3 locations. Oops, that wasn't drawn very well. Let me try that again. That's 3 locations because I had 3 numbers. and I need to move it 3 more, so I'm going to need 3 zeros in front. So I have a decimal point followed by 3 zeros, and then a 365 decimeters cubed. C is messy because it's not metric, right? Inches and yards. Now, you may actually be able to think through that and know your inches to yards. If not, you could also go between feet, right? I'm going to do it with the feet involved just because I want you to see the multi-step process in case there was a place where you needed to use it. How many inches are there in a foot? 12. 12 first. I'm not going to use the cubic ones. You can though, Hannah, if you want to. So there are 12 inches in 1 foot, but I need it to be cubic inches, which means I actually need to cube both of these quantities, which will in fact change the 12 to 12 cubed. But I don't want feet, I want yards. So how many feet are there in 1 yard? 3 feet in 1 yard. And again, I need the measurements to be cubed. So what I end up with is 874 here. I have 12 cubed here, and I have 3 cubed here. So maybe it would be helpful for us to just find the values for a moment. What is 12 cubed? Okay, and what is 3 cubed? 27. So we're going to have 874 divided by 1728, and then you can either hit divided by 27 again, or you can multiply 1728 and the 27 together first and use that as the denominator. Just make sure your calculator is doing it in the right order. What is 874 divided by 1728 times 27? I have something else written down. 019 is what I have. Okay, good. So we're just missing the 1. That's right. And I know we normally do 2 decimals, but it kind of feels funny to put 0.02 here. So I usually encourage you to put 2 decimals that are not 0. If it starts out with a bunch of zeros, give me a couple of non-zero digits would be a good plan. What are my units here? Yards cubed, or cubic yards, yes.
So did we multiply the 728 by the 27?
Yes.
And then we divided 874 by that?
Exactly.
Okay. So could you take 874 divided by the first number and then divide your answer by the next number?
Yep.
Okay.
Both of those will work. Very good. Now let's try D. This is gallons and cubic feet, and one of those is cubed and the other one's not, right? So not only that, but also gallons and feet are not metric measurements, right? They're English standard measurements. So let's come over here and see if we can find some kind of relationship that will help us out. Maybe one more back even. How far back am I going to have to go? Oh, that's probably my slide. I need gallons to cubic feet. Do you see a relationship here? Oh, there's one. Okay, so I can turn gallons into cubic inches. And then I know how to do inches into feet. So that's the facts we're going to be needing.
Did
So
you write all these on your note card? Like all the versions?
I would write all the ones that you don't know. Like if I were you, I wouldn't write the feet and inches one here because you can figure it out if you need it. And you really only have so much space on your card. But for the ones like the gallons and cubic inches, I'd probably write that one down. Yep. It's a good question, Lacey. All right, so there's 1 gallon to 231 cubic inches, right? So I've got 37 gallons. And the relationship is that I have 1 gallon to 231 cubic inches. But then I need to turn my inches into feet. So what's the relationship for feet and inches? 1 foot is 12 inches, but I'm working with cubes, so I do need to cube them, right? We just saw that that was 1728 a minute ago, so I'll go ahead and jot that down. So on this one, you're going to multiply 37 times 231, and then divide that by the 1728, right? All right, what do we get for this particular problem? 4.95 cubic feet. Good job. Yes.
So, why did we not cube the inches because it was already?
It was already a measurement in the table that was already cubed.
Okay.
Yes, that relationship already had it there. Well, the reason that we cubed it when we did was because we knew the linear relationship. And we were writing down the relationship between feet and inches in the linear relationship. That's why. All right, 97 cups into something involving inches. All right, there's at least 2 ways to do this particular problem. I've got one of them written down. I won't reference it because I want you to take a look. It's got to be over here because it's cups and, what did I have? Cubic inches. So how are we going to get cups into cubic inches? There's more than one option here, so somebody give me an option.
I think cups to gallons to the cubic inches.
Okay, so you want to go from cups to gallons, and then gallons will move us into cubic inches. Is that okay with everyone? Okay, that's what I have written down actually, so we'll go with that route. So we have our 97 cups. If you're thinking about gallon gal, or gallon guy, or whatever, do you remember how many cups there are per gallon? Good, so the number of cups per gallon is actually 16 cups in 1 gallon. You can count it up, it's on his hands and feet or whatever. And then I'm going to be able to turn gallons into cubic inches because that's in my table. 1 gallon was 231 cubic inches. No need to cube anything on this one because the relationship is a capacity relationship. So you can either do 97 divide by 16 and then multiply by 231, or 97 times the 231 and then divide by the 16. Either of the orders will give you the same quantity. What value do you get?
1400.44.
And it's cubic inches, right, Alyssa? Yes. Very good. Yes, ma'am.
Okay, I'm just dying to know when, is there an example where we would ever convert meters or inches to gallons? Because it's kind of weird since this is
Yeah, so
linear measure and then liquid.
everything that we're doing in this section is either within the metric system or within the English system. It's not converting between.
Right.
So we're not doing any conversions between English and metric.
But what I'm confused about is if you have 37 gallons of milk, how would you convert that to feet? Why would you need to convert that to feet?
Space. Imagine that you were taking that milk and you were trying to fill up a rectangular tub or something like that. It's a space issue.
Okay.
And so you're trying to get the length, width, and height of the box, the rectangular box. Yeah, that's what you would be doing. Or vice versa, trying to take those length, width, and height and pour it into bottles, something like that. That's the difference between these. Yeah. All right. Moving into a little bit different direction. We're going to talk about some volume now. We did conversions basically so far. These are volume measurements. We're looking at volume first of prisms. So we have this first shape, which is a right rectangular prism. And I'll bet that you guys know how to find the volume of a right rectangular prism. Do you remember? Yeah. Length times width times height. That is the way we find the volume of a right rectangular prism. It's really not that much different when we do it for an oblique prism or for something that's not a rectangle. What we've really done in this formula is we've taken this base and we've multiplied it by how tall it is. And we can do the same thing down here. If we found the base of this parallelogram or rectangle or triangle and we multiplied it by the height could be a straight up, it is a straight up and down height, but it could be the height where it's going like this, right? This object's oblique, so it's tilted, but it's still the perpendicular height we're talking about. That's still how we find the volume. So in general, the way we're going to find the volume is we're going to find the base times the height. And this base is the area of the base that it's referencing. So that capital B is standing for the area of the base, just like it did when we were talking about surface area. Okay, area of the base. And that makes it more broad and able to be used for other shapes if we think about it that way. All right, so moving into some other objects. This one is a right circular cylinder. The volume is done the same way. It's the area of the base, but the area of the base is the area of a circle. And the area of a circle is pi r squared. And then, of course, that's times the height, right? So in a very real way, this is the exact same formula I just wrote down. I just have a base that happens to be a circle. And the same is going to be true for the oblique shape down here. It's just that the height is perpendicular, even though the object itself is tilted or slanted, right? Thinking Leaning Tower of Pisa when you see something like that, right? Same idea. So the volumes in each of these cases are still the base times the height. It's just that our base in this particular case was pi r squared. And over here as well, because this one is a circle, or at least it appears that way from the way that they've drawn the picture. Pyramids and cones are a little bit different. You obviously have a base, whatever the shape is, a polygon or a circle for the base. And the difference in finding their volume is that instead of having just the base times the height, you actually have 1/3 the base times the height. And the same is true for your cone.
And all of these bases are the area.
Yeah, it's the area of the bases. Now, obviously the area of the first base for the pyramid is the area of a square or a rectangle. That's what it looks like, right? And the area of the second shape is actually the area of a circle, or maybe an oval if we were dealing with an oblique shape, or not oblique, but a non-circular shape. But it's the area of whatever the base is, still times the height. The only difference for cones and pyramids is that you've got a 1/3 factor in it instead of not having the 1/3 for the other shapes we're dealing with. The volume of a sphere is just weird. It doesn't have the same nice relationship that some of the others had. It's 4/3 pi r cubed. Shouldn't surprise you probably that it's r cubed, right? Area is r squared, so volume is going to give you the r cubed. The scale factor is actually a 4/3 in this case, as opposed to a 1/3 for the other 1/3. That's bad. 1/3 for the other ones. All right, so we're going to do some examples. Ice cream cone. If you were to actually fill up the entire ice cream cone with ice cream, and then you had the top part of it as well, you could ask yourself exactly how much ice cream are you eating. And if you were doing something like watching your weight or trying to figure out how much ice cream you ate, this would actually be a fairly practical thing, because ice cream is usually, when you look at the back of the carton, measured in a number of cups. How many cups of it did you eat? Well, it depends. Well, first of all, it depends on how much I can cram into the cup. But besides that, it depends on the size of the cone, right? If the ice cream is going all the way down to the bottom of the cone. And that's what we're looking at for this particular problem. So we're going to find the volume of the ice cream cone. So to find the volume of the ice cream cone, there are two parts to this ice cream cone. What are they? We've got a hemisphere. And we've got a cone, right? The cone itself. Okay, so the volume for the hemisphere, well, the volume for the sphere was 4/3 pi r cubed. So what would it be for a hemisphere? Half that. So half of 4/3 is 2/3, right? So you can just do that right here. Divide your 4 by 2, so you get 2/3 pi r cubed. What was the area for the cone? It was 1/3 the base times the height. But the base of our cone is the shape of a what? It's a circle. So what's the area of a circle? Pi times r squared. So by making substitutions appropriately with formulas for the components that we have, this is what our formula would look like for the volume of the shape that we are given. We're assuming the way that the picture is drawn that the 4 centimeters is the radius, right? And the 8 centimeters is the height. And I think those are the only variables that we have in this formula. So you've got your pi, your radius is 4, and your height is 8. You know, it's kind of messy. But your calculator can handle messy with no problem. So don't worry about the messy. What do you get? Again, we're doing decimal approximations, 2 decimal places, for the volume of the ice cream, or the volume of the ice cream cone. All together. What'd you get, Alyssa?
I got 268.08.
Oh, I heard a confirmation. Is everybody good with that? Okay. Centimeters cubed is what I have written down. Does that look right to you guys?
Yeah.
So make sure when you're doing these, you're putting the units on there that are appropriate to what the problem is. All right. Volume of a right triangular prism. So, Veronica, this almost looks like that tent problem you had, right? From the problems that we just did. But we're finding not the surface area on this one, but the volume of it, right? So volume in this case would be sort of like the amount of space you have inside the tent to stand up and walk around. That's kind of what you'd be looking at. All right, so the volume for this would be what? How would I find the volume of this tent? The area of the base, and then what? Times the height. So what shape is the base in this picture? It's a triangle. This is my base. And this is my height. Okay? So the base is actually a triangle in this case. And the area for a base being a triangle would be 1/2 base times the height. And this height is the height of the triangle. And this height is the height of the prism. So be very careful. These are not the same heights. If you want to label them as like H1 and H2, that wouldn't be a bad idea. So in terms of the picture over here, the 12 centimeters is H2. Yellow is just terrible for writing with. Choose something different. Okay, so how are we going to find the area of this particular triangle? Yeah, it's 1/2 and then it's 6 times 6, right? That's the area of the triangle. And then what's the height of the prism? That's my 12. So I've got 1/2 times 6 times 6 times 12, which gives me what? 216 cubic centimeters. Okay, the next one does not give you a picture, but I think you have a good enough imagination to picture it. A standard straight drinking straw is 25 centimeters long and 4 millimeters in diameter. How much liquid can be held in the straw at one time? If you guys ever played the game, it's a youth activity is what it is, like in church, and you like fill up the straws and you got to run across the room and dump them into something else. You're trying to get the liquid across the room. This is what this is talking about basically. All right, what shape do you have? It's a cylinder, and of course I'm drawing it extra big, otherwise it's hard to draw. So there's my cylinder. So let's figure out some of the information we know. It says it's 25 centimeters long. It says the diameter, which is this length, is 4 millimeters. And it wants us to find the volume. So how do we find volume of a cylinder? Base times height. The base in this particular diagram is a what? A circle. So it's pi, r squared, and then times my height. Do you know r, do you know h, and do you see that we have a problem? Yeah, we need either everything in centimeters or everything in millimeters, right? We can't have both of those things going on. So which conversion do you want to make? Do you want to make it into centimeters or into millimeters? Either's fine, just we need to decide. Heard both. Centimeters I've heard most. So we're going centimeters. 4 millimeters is how many centimeters? 0.4 centimeters. But 0.4 centimeters is the what dimension? The diameter. And we need the radius. So what is the radius of our straw? 0.2. And our height is 25. So we need pi times 0.2 squared times 25. No. We're going to go with decimals, and the reason that we are, depending on what level kids you're working with, sometimes they leave them with pi and sometimes they don't. The reason that I tend to say no is because if you were telling somebody how much volume were in something and you left your answer in terms of pi, in a practical sense, people would look at you like you were off your rocker. Because these are application problems which don't really make sense to be left in terms of pi. So, did you guys get a number? What was it? Did you multiply by the pi?
Yeah.
Okay, what did you get? No, I don't want an answer for pi. I want an answer for all of it. Sorry.
Squared times 25 is 1.
Oh, I see what you're saying. So you've got 3.14.
Yeah.
Okay, fantastic. Sorry about that. Centimeters cubed?
Yes.
Yeah, because we did it in centimeters. So centimeters cubed. I'm with you now. Gotcha. Okay, we are so running out of time. I've got one slide left, and then I'm going to have to post what I've got for the rest because I can't push it back. I can't push test back or running in presentations. This is the problem I'm running into. Okay, so here's the deal. Mass versus weight. Mass is the amount of matter in an object. Weight is how much force gravity exerts on an object. Who's been to the Science Museum or been on one of those scales where it tells you how much you weigh on the moon? Have you done that before? Okay. It depends on gravity as to what your weight is, but your mass, like how much of you there is, doesn't depend on the moon or gravity. Okay, so that's the difference. Weight changes when the amount of gravity changes. Mass is not affected by gravity. The English units for weight are pounds and tons. Have you guys heard of English tons before? Sometimes see them on bridges. They'll tell you if you're over a certain tons, or if you're driving somewhere and they want the trucks to pull over, they're over a certain amount of tons. 1 pound is 16 ounces, which you probably knew that one. 1 ton is 2,000 pounds. Okay? And the metric units for mass are based on the gram. You don't really need to fill this in. I mean, you can, but you probably know it. These are all the units for mass in metric. Yes, you can. All of the stuff with grams still works with King Henry died by drinking chocolate milk. The next slide, though, which you don't need to write down because it's already in your notes as is one that I would definitely write down as a useful piece of information for your tests because it doesn't work with King Henry. 1 cubic centimeter is equal to 1 milliliter, which is equal to 1 gram. That's kind of a cool fact. Cubic centimeters, milliliters, and grams are the same. And how handy is that? Super handy. A decimeter cubed is the same as a liter and is the same as a kilogram. Okay? So what I will do when I get back to my office this afternoon is I will record. I will have to stop this video now, otherwise Actually, I won't because I don't have new material to present in my next class. So I will pick up on this video where I'm leaving. No, that's probably not a good plan. I'm going to stop it. There will be a third video in section 14.5. So if you're here today in class, then you don't need to rewatch part B of this video or whatever. You just need to look at the third part, which it'll say part 3, not C, but it'll say part 3. And then I'll have the rest of these examples and the information about temperature. Okay?